predator becomes prey in the Florida Everglades as hundreds of hunters descend on the Sunshine State to catch and kill as many Burmese pythons as possible.
Every year, fire crews in Everglades National Park deliberately set portions of the sawgrass prairie and pine forest ablaze, a practice that traces back to 1958 when the park conducted the first prescribed burn in the history of the entire National Park Service. The goal has always been ecological, mimicking the natural lightning-driven fires that Everglades vegetation evolved alongside for thousands of years, clearing dead growth, recycling nutrients into the region's notoriously poor soil, and keeping the landscape from becoming so overgrown that an accidental wildfire could burn catastrophically out of control. What decades of that same fire management have gradually revealed, though, is a far bigger picture of exactly what has moved into the Everglades over the past half-century, and pythons turn out to be only one part of it. Before we get into how that happened, if you're into real, deeply researched nature stories like this one, hit like, drop a comment, and subscribe now so you don't miss the next one. Fire and the Everglades have a relationship stretching back long before any land manager thought to schedule one deliberately. Sawgrass prairies here naturally burn every 1 to 3 years, and pine forests on slightly higher ground burn on their own particular rhythm, both ecosystems having evolved specific plant traits, including bark and growth patterns built to survive regular low-intensity fire, precisely because lightning strikes across this subtropical landscape made fire a routine and expected visitor for millennia. Decades of fire suppression during the 20th century, driven by the same instinct that led much of the rest of the country to treat every fire as an emergency to extinguish, actually left large sections of the Everglades more vulnerable to sudden climate stress and drought, since removing routine, low-intensity fire from a fire-adapted ecosystem doesn't eliminate fire risk. It simply lets fuel accumulate until a fire eventually comes anyway, usually a far more destructive one. Restoring regular, carefully planned, prescribed burns became a central part of how the park manages the landscape, and in the process, fire crews and researchers working these burns have had a front-row seat to watching invasive species interact with the landscape in ways ordinary daytime wildlife surveys rarely capture. Burmese pythons are the invader most people associate with the Everglades, and for good reason. Since establishing a breeding population sometime before 2000, pythons have been directly linked to catastrophic mammal declines throughout the park, with road surveys documenting raccoon sightings dropping by more than 99%, opossum sightings by nearly 99%, and rabbit sightings disappearing from certain survey routes entirely. But pythons share the burned and burning landscape with an entire additional cast of invasive species that fire management has had to account for just as seriously. The scientists who first pinpointed how completely Florida's native mammal populations had collapsed made their discovery almost by accident through exactly the kind of long-running survey work that fire management depends on. Researchers driving nighttime road surveys through Everglades National Park in the years before 2000 routinely spotted raccoons, opossums, and rabbits at regular intervals, animals so common along these roads that recording their presence had become a fairly unremarkable part of the fieldwork. When those same surveys, covering nearly 57,000 kilometers of driving between 2003 and 2011, came back showing those species had all but vanished from the same stretches of road, the researchers realized they were documenting something far larger than a routine population fluctuation. The timing and geography of the decline matched the python invasion spread so precisely that the two were impossible to separate. A finding that first alerted much of the scientific community to just how severely a single invasive predator could restructure an entire regional food web. Argentine black and white tegus, large, intelligent lizards native to South America, have established their own breeding population across South Florida, moving through the same canals and levees originally built to drain the Everglades for agriculture, infrastructure that functions for tegus much the way it does for pythons, an artificial highway network cutting straight through habitat that would otherwise slow an invasive reptile's spread considerably. Tegus prey directly on the eggs of gopher tortoises, a species already considered threatened, along with a wide range of other ground-nesting reptiles, birds, and small animals, and researchers have specifically flagged them, alongside pythons, as a primary target of ongoing invasive reptile research and control efforts across the greater Everglades ecosystem. Invasive plants have proven just as consequential to how fire actually behaves across the landscape in ways that go well beyond simply providing more fuel to burn. Melaleuca, a fast-growing tree introduced from Australia, contains oily compounds in its leaves that burn dramatically hotter and fiercer than the vegetation native to the Everglades, producing fires intense enough to reach the canopy and throw embers considerable distances on the wind. Fire also triggers something Melaleuca has specifically evolved for in its native range. Heat causes its seed pods to burst open, releasing enormous quantities of seed directly into the newly cleared sunlit ground a fire leaves behind. One study documented nearly 600 Melaleuca seedlings sprouting per square meter in the aftermath of a single wildfire, meaning a fire intended to help restore native habitat can, if Melaleuca is already present, end up supercharging the very invasion it was meant to control. The Brazilian pepper tree presents fire managers with almost the opposite problem. Rather than burning explosively, dense stands of Brazilian pepper have been observed actively suppressing the spread of controlled burns, disrupting the low-intensity fire regime the surrounding native sawgrass and pineland depend on to stay healthy. Old World climbing fern adds yet another complication, draping over native cypress trees and forming what land managers describe as a fire ladder, a continuous path of flammable material connecting the ground directly up into the tree canopy, allowing fire to reach and kill cypress crowns that never evolved any resistance to burning at that height in the first place, since native cypress trees historically stayed below the reach of ground-level Everglades fire entirely. Detecting exactly which of these species are present in any given area, ahead of a planned burn or otherwise, has become its own significant technical challenge, since both pythons and tegus are notoriously difficult to spot by eye across dense, often flooded Everglades terrain. Researchers have increasingly turned to environmental DNA sampling, a technique that detects trace genetic material an animal sheds into its surrounding water or soil, as a way to confirm a species' presence in a given burn unit, even when no individual animal has actually been seen. A team at the University of Florida recently developed a specialized genetic test capable of simultaneously screening for 4 different invasive constrictor snake species from a single water sample, a tool designed specifically to give land managers, including those planning prescribed fire units, a clearer, faster picture of which invasive reptiles are actually present in a given stretch of the park before crews ever light a match. Each of these species requires its own tailored management response layered directly into how and when prescribed burns are planned, turning what once would have been a relatively straightforward ecological practice into a far more complicated exercise in invasive species triage. Fire crews now have to account for whether Melaleuca is present in a burn unit and plan follow-up herbicide or mechanical treatment for the seedling flush a fire will trigger, assess whether Brazilian pepper density might prevent a planned burn from carrying properly across a unit at all, and coordinate timing around the reptile survey and removal efforts targeting pythons and tegus in the same general area, since a scheduled burn can temporarily concentrate or displace both species as they flee cleared, exposed ground in search of remaining cover. Recent research has uncovered an entirely different way pythons interact with the broader landscape fire managers are trying to protect, one that has nothing to do with predation at all. Biologists examining stomach and digestive tract contents collected from pythons removed through ongoing control efforts documented 25 distinct seed types inside the snakes, including native Everglades species like cabbage palm and creeping. Cucumber, evidence that pythons may be functioning as unintentional secondary seed dispersers. The mechanism works indirectly. Pythons eat birds and mammals that had themselves already eaten fruit, and some of those seeds survive the python's digestive process intact enough to germinate later wherever the snake happens to travel and eventually defecate. A test specifically examining cabbage palm seeds recovered this way found nearly 40% successfully germinated after passing through a python's gut, meaning the same predator responsible for gutting the Everglades' native mammal populations may also, as an unplanned side effect, be quietly reshaping where both native and invasive plants end up taking root next, adding yet another layer of complexity to how fire, vegetation, and invasive wildlife all continue interacting across the same burned and burning landscape. Water management changes made elsewhere in the Everglades, largely undertaken with the best of restoration intentions, have compounded these interacting problems rather than simplifying them. The same multi-billion-dollar effort to restore the Everglades' natural water flow, plugging old drainage canals to rehydrate the wetland the way it functioned before large-scale agricultural drainage began, inadvertently created new deep-water ponds in some areas, habitat where invasive fish species can now survive winter cold snaps that would previously have killed them off, allowing those fish populations to establish and breed in places they never could have persisted before. Researchers studying invasive crayfish populations in the park documented declines exceeding 99% in some areas, a drop so steep that biologists working the site described being genuinely startled that a change of this scale had gone unnoticed for as long as it had, since crayfish and small native fish form a critical food source for the wading birds, herons, egrets, ibises, spoonbills, and storks that congregate in the Everglades specifically to breed. Modern prescribed fire planning at Everglades National Park reflects just how much this layered set of considerations has changed the practice since that first 1958 burn. Fire managers now spend months, sometimes years, preparing a single burn unit, tracking weather patterns, wind direction, humidity, water levels, and fuel moisture to identify a safe and ecologically effective window, while also coordinating with the Miccosukee tribe of Indians of Florida under a formal co-stewardship agreement to protect nearby tribal communities from smoke and fire risk. The park has also moved away from older, rigid block-burning schedules toward fire regimes designed to more closely mimic the natural, lightning-driven patterns the landscape evolved with in the first place, an approach that requires far more site-specific knowledge, including exactly which invasive species are present and how they're likely to respond, than the simpler scheduling practices used decades earlier. Taken together, the picture that emerges from decades of fire management and the research surrounding it is considerably more tangled than a single invasive predator working its way through a vulnerable ecosystem. Florida now hosts more non-native species than any other continental region in the world, and researchers surveying South Florida's urban parks have found that 93% of the reptiles and amphibians they observe there are non-native, a proportion that drops in protected habitat like the Everglades itself, but remains high enough that land managers increasingly describe their work less as eliminating any single invader and more as trying to hold an entire, interconnected web of introduced species to some kind of manageable equilibrium. Every prescribed fire lit across the sawgrass and pineland today burns through exactly that tangled web, clearing native vegetation the ecosystem depends on while simultaneously interacting with melaleuca seed banks, Brazilian pepper thickets, climbing fern ladders, and the pythons and tegus using the same disturbed, newly opened ground to move, hunt, and hide all over again. Florida's invasive species crisis extends well beyond the handful of headline-grabbing reptiles most people have heard of, and the scale of it helps explain why fire management alone was never going to be a complete solution. Researchers tracking non-native species across the state have documented more than 500 established populations spanning reptiles, mammals, birds, fish, insects, and plants, making Florida home to more invasive animal species than any other state in the country and trailing only California in overall invasive species when both plants and animals are counted together. Many of these species share the same underlying advantage that let pythons and tegus thrive. A subtropical climate similar enough to their native range, that establishment posed little biological challenge, combined with a dense, well-connected network of canals, roads, and altered waterways that let new arrivals disperse across the landscape far faster than they could have under natural conditions. Fire management, water restoration, and reptile removal efforts all now operate within that same crowded, interconnected reality. Each program forced to account for how its work will interact with a dozen other invasive species, problems happening in the same square mile of wetland at the same time. Land managers weighing all of this have increasingly settled on a working philosophy that treats complete eradication as an unrealistic goal for most of these species, and instead focuses resources on protecting the specific native populations most at risk. Officials overseeing python control efforts have been explicit about this shift in expectations, noting that the vast, often impenetrable terrain of the Everglades makes full elimination of a species this well-camouflaged essentially impossible, and that the more realistic aim is containing python numbers enough to give vulnerable species, including the endangered Key Largo woodrat and the native cottonmouse, a viable path to survival alongside the invasion rather than in spite of it. Fire fits into that same recalibrated strategy, no longer treated as a tool capable of resetting the Everglades back to some pre-invasion baseline, but as one part of an ongoing multi-front effort to keep the ecosystem's most fire-dependent native habitats functioning even while a growing list of invasive species continues sharing the same burned, regrowing ground. If you enjoy real verified stories from the wild edges of nature, like this video, leave a comment letting me know what you thought and subscribe for more. I will see you in the next one.